What's up, YouTube? We're back at it again with another video. I don't record too many videos per day. I'm going to teach you how to create or code your own smart contract for your own ubiquitous purposes if you want to, for business reasons, potentially creative reasons. Who cares? Who knows why you want to make your own NFT? It has a lot of creative aspects, but this is how you code one. Uh, Very simple. I'm gonna get straight to it. So the goal of the video is, so you can't mint it right now. This is my portfolio page, for example. Get out of the way. So usually you would mint it. Well, first I'm not on the Ring B network, but usually you will mint. Let me get to the Ring B. So usually you will mint it, but I can't mint it because I've reached the max number of mints. I coded in smart contract earlier where a user is only able to have one of my set portfolio NFTs. But anyways, let's get straight into the video. What you're gonna need for your development environment is Node.js already installed. You need to create yourself an Alchemy account. We will be using this, and you need to create a crypto wallet. MetaMask is the most known one. I don't think it's the best one, saying that they ban people in like Portugal, Brazil from their accounts. I'm like, what? This is supposed to be decentralized, but I told you how early we are. And you're gonna need to create a Panada account because this is where we're gonna store our metadata. But anyways, let's get straight into it, guys. Let me get my stuff available. Why is it looking like that? Second slow. Let's get straight to it, guys. There's study. Alright, let's get straight to it. Video NFT. What's this? I'll have this up on the side. Let's have my. Alright, guys. Once you have Visual Studio downloaded, you want to install your contract. How do we do that? Well, I'm gonna copy and paste everything. First, actually, let's make a directory called video, or call it contract, or any tutorial on. I'm gonna call it video contract. Now, I'm a CD stands for change directory. So you're changing your state to a different directory, like changing, yeah. CD video contract. Okay, now we're in here. We want npm init. Yes, we want to initialize this. We will initialize npm. Now it's npm install -- save dev hard hat. Or which hard hat? This creates a local blockchain on your computer, and Alchemy is going to be the backend or the middleman service that allows us to connect to the Ethereum blockchain. So is Web3 decentralized in this matter? No, because you're still using a third-party intermediary. So I don't know why people are so excited with Web3. I don't even know, but it works. Okay, once you install that, you do want to copy and paste this. If you're on Windows, if you're not on Windows and you're on Linux and Mac OS, pretty sure you don't need this, but I'll take y'all get a good look at it. I'm gonna enter that bad boy, and while this waits, are y'all having a beautiful day today? I hope you all are having a beautiful day, and you go chase your dreams and goals, all that that motivational 2016 nonsense. We ain't here motivational, we either action. But it's exciting. So let's see what this does, why it's fetching, doing all this dependency downloading. While that loads, let's see what's going on. See my plans in the background? You know how you planning. Plan. We all plan, don't we? Alright, clear. I like seeing that. Okay, it's NPX hard hat. Let's start this bad boy up. And once that does that, we'll see what happens. You want to create a basic sample project? I don't know TypeScript, so yes. What are you doing? Oh. Yes. Alright, clear. Now you see in our file system we have contracts, node miles, scripts, tests. You gotta make sure contract doing what it's supposed to do. We won't be dealing in tests today since the contract we're building is gonna be very simple compared to oh snap, sorry. compared to like a huge contract, so I'm not gonna trip too much on that. But let's go to contracts and let's create a new file. Let's call this ERC 725, right? 25 contract. That was 721. Anyway, it's not so. ERC 725 or 721. Please don't quote right now, but it is the Ethereum standard of an NFT contract. We will get straight into that later. Probably some other videos. All right. So in most smart contracts, they require you to have this thing right here. This XPX license identifier and the compiler version of the current compiler version of Solidity. So right now I'm hitting MIT. I know that's very functional. And since we're not going to build a full smart contract from scratch, we will be building one using the Open Zeppelin library, which I would love to show y'all since y'all asked. What is Open Zeppelin? Let's show you Open Zeppelin. Excuse me. Open Zeppelin, I'm going to go to docs. Open Zeppelin is a library to help you build and manage stuff for Ethereum, pretty much. So it makes you, it really gives you, it makes, like, for example, it makes the process of creating a smart contract less overbearing for the developer purpose and goals, because that would suck. That'd be so inefficient in code if you had to always recreate your own smart contract. It's 2022, baby. We use open source software over here, guys. But anyways, so here, let's npm install Open Zeppelin into our environment. I'll flash it up. Oh, it has this right here. Still doing that thing, ain't it? Okay. There we go. Let's see what this does. Yeah, we wrapping up. It doesn't install. Probably forgetting something. Probably not. Anyways, let's get what we need imported to our contract environment. Boom. We need all this stuff. We need to be able to access our ERC 721. I knew it was 721, guys. I just can't have that. I can't have that bad. The 721 token. We want it to be enumerable and we want ownable. We want the contract to be able to call is owner, which is me, the baby, the owner. So let me see. Anyway, let's get straight to it. If you're familiar with any object-oriented programming language, you can create classes. A contract has the same format as a class, where you would, like an object, where you would put the brackets. But instead of that, we're gonna create a contract. And in most of all contracts need a name. In this contract, we're gonna call it video NFTs. It is ERC 721. You know, it depends on who you're talking to. They might do 721. They might do just ERC 721. Somebody do Evis. Somebody do ERC 720 and no comma. And you also want to make it ownable. So this is the way you be able to call the owner function on it. So I don't want to lead y'all the wrong way why Open Zeppelin does this. So let me implement this real quick, and it probably wasn't tell you. Okay, let me tell you. I think this just has different type of through ERC. Yeah, here ERC 20 gives you these functions. When you call this, you're able to use tokens of total supply, all those cool functions and stuff. Let's get straight into it. So in a smart contract, what is usually the guts of it? What do you need to have in a smart contract? So one thing we need to have to access the data of the smart contract, whether it be a description of, every smart contract has a description, has a name, has a token supply, has attributes depending on the NFT. It's so fluid. That is usually stored in the metadata. How do you get the metadata in the smart contract? They usually call it the base URI. So we have to get metadata from the smart contract, and we can initialize this in Solidity. Solidity, it classifies its strings and integers and its variables like this. Unlike JavaScript where you do const blah equals hello, that will enter a string, or integer would be 20, or non-integer would be -20. You get right. Or in Solidity, you do string, and I'm gonna call it base URI. That's how you get a string right there. Simple. String it is the variable bar is a string. If you want to make it public, you do public. If you want to make it private, you do private. If you want to make it public constant, do public constant. But in our case, it just needs to be this. Okay, what else does a smart contract need besides access to metadata? A smart contract needs to be able to. I'm gonna write like this. I'm thinking, I'm gonna write all it needs so I don't get confused. It needs to get the metadata. Data, we call that the base URI. Needs to have a max total supply of tokens. A lot of supplies either have 10,000, 10,000 to 10, but it depends. You want to keep track of total supply of minted tokens, which means we need a counter in our code. For my purposes, I wanted to add this. I want to limit, because I'm pretty sure it depends on, some contracts give the user ability to mint up to 3, or mint this many. But in our case, we want them to be able to mint, say, 2 contracts out of 20. So let's do this. So set user has max number of mints. Okay, so we have to get the metadata, max token supply, keep track of supply minted tokens, max number of mints. And an interesting one I want to do in an old contract, do I have it? Because I will utilize it if I do. I don't think I am. I don't think. And yeah, I guess it is. And to be able to pause the contract. So let's do this. We got string equal base URI, which is our metadata. We have unassigned integer, which is a non-negative number, and it goes to 256 because in Solidity programming language it goes up to 0 to 256 bytes. Please don't quote me on that. Then it reverts all the way back to 0. So if something's over the 256 length, it doesn't work unless you enter some, like, use some backend code, like some import to fix that problem. Anyways, we want to get the max number of token, which I'm gonna have 20 tokens in this case. Alright, name public max tokens 20. Alright, then let's keep track. That don't look right. Why? Oh, it was 20. Yeah. I was like, why didn't that look right? Then you want to keep track of 2050 counter public token IDs. That's to keep track of tokens. This is max number of mints. Getting brazy out here, bud. I'm gonna talk like that. No, it's getting a little cool out there, guys. Allow user or message.sender. What message.sender is the person who's calling the contract. This is gonna come back later in the code. Person who's calling the contract or pressing the button from this front end. Like, I will be the message.sender in this case. To only mint 2 NFTs. So unit message sender. I was looking at some code, I'm not gonna lie. I was like, what am I doing? Public message sender equals to. And I guess to be able to pause the NFTs, right? Because if something happens to my contract, you want to pause that boy. You can't mint no more. It's breaking up. Something's going wrong. Okay, it's called. It's gonna be a truthy. It's gonna be like, this is true, this is not true. So they go woo, 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 public pause. Yeah, you don't want none of that happen. So in the Untitled contract, I do want to show y'all guys in the ERC contract, we have our constructor function. Let's go to ERC 21. Right here. This is what we will be using right here. The constructor function. A constructor is an object that gets called on the initialization of the contract or any code. When you call the code, this starts. A lot of code has this. I want more beanies. I'm gonna go actually go to the store and get some beanies after this. Swag. Alright, stop playing. It's stop playing. Constructor, let's get that, guys. Boom. That's not what we're gonna call our thing. In our thing, like for this, it doesn't call the metadata. For us, we do. So, how do we get the metadata? Within the structure, we're gonna classify a string and we're gonna call it from memory. So in Solidity, there's something called memory. You can access memory. Oh my god. Or you access storage. Storage is slower. That's all I'm gonna say. Memory, and we're gonna call it base URI. When we call it ERC, we don't need all this. ERC 721. We're gonna call it joint video SID. Video NFTs. We call it VNF. And yeah, public. Do we need to be public? Yeah, it gotta be public. Return, right? I don't remember ever being like that. I remember having public. That's what I'm like messed up. I'm not gonna have public personally. I don't remember having you. But anyways, we gonna classify as that our base URI is not equal to base URI, right? Cool. It's simple. Now we got that. Now let's create the gut and meat of the function. ERC 21 has pretty much two things in the contract. A simple one at least. The mint the NFT, the set the metadata, and deposit potentially. Alright, let's create the mint function. This is not no pre-sale. It's gonna be simple giant. So we call function mint. That's what it's called. This function is public. It's access to any person, like me, you, everyone on the net, guys. It's payable. This allows the function to be pretty much a payable contract. I don't know pretty much how to put it. Alright. Only when not pause. I didn't even. Is there like something I didn't do well enough? Oh yeah, I didn't set the modifier, guys. Modifier only when not pause is required. My pause contract currently pause. In case something happens, you know, you want something happens in the contract. Heck. Why are you like this? So there's certain things in the contract you want to have. Like, you probably like, what does this mean? Well, we're going to explain that in this part of the contract, the required statement. So in a mint contract, you don't want people to mint. You don't want people to call a contract and there's no more NFTs to mint. Like, we have ran over the token count. So let's say it says, don't allow messages. Instead of using user, we use message.sender. So we understand what this means. Message.sender is the same as the user in the front end. Don't allow the message sender to be able to mint a NFT if there are none. Right? That's simple, right? And that's where the token IDs come in, right? we require the token IDs to be, if token IDs is greater, yeah, the token ID is less than max. Well, greater if max token ID. If max token IDs is greater than token ID, if token IDs is greater than max token IDs, exceed max number of mints. Right? That looks right. All right, right. We also, if user sends the wrong amount or not enough ether, strike up a great notification. So we require measures.value, which instantly gets the value, the money. Will be specified more on this a little later. It's greater than equal than. I didn't set the price, guys. No one told me to say that, and it is the price of the NFT. That's crazy. Unit 256 public price equal 0.001 ether. It's cheap as it. Yeah, it's gonna be like a cheap NFT. So it's easy to mint. So you know you have enough ether in your rank B wallet to mint this, which is cool. All right. Anyways, require measure.value to be greater or equal than the price, right? If not, ether sent not correct. You know the basic gist of the things. Nice. Okay, if all this, okay. Oh yeah, I forgot. We want to allow the user to be able to mint too. So this is how we do. We gotta check the balance of the measures.sender. How do we do that? To make sure he has 2 or less. How do we do that? We should require a statement. Balance of measures.sender. Person contract. Boom. Too. After that, they exceed max number of NFTs. Okay. If all these goes through, nothing. None of the people had none of this. Boom. Allow the token IDs. But it's you, right? Yep. Right. Ooh, yeah. Ooh, what happened? IDs increment. Cool. Now we call this function from the ERC standard that just makes that allows the mint to go smoothly. Okay, I would say it's called safe mint. It takes the message.sender to call it and the token ID. Cool. Yeah, why are you looking like that? Now I do want to actually verify this because safe mint open. Yeah. What did he say? Oh shit! There we go. It reverses the token ID already exists, so we ain't doing no extra stuff on the extra. You hear me? Okay. All right. Let's create this next function. Right. We might use this function. This returns the balance of currently connected account. Or just say message.sender. Do I need it? Okay, yeah. Function return token ID. It's a public function. So this is cool. You learned something new. The public function is a view function, so it allows whoever calling the contract to view this item on the blockchain. It's a view. I'm looking at you, and that's all. It's public. A view, not access. You're not sending money. It's public view, and it returns unassigned integer, of course, because we're looking at number, and just gonna be called token, and return balance of message.sender which is it returns assign integer. Cool, guys. This I'm just gonna copy and paste. Function base UR eternal view virtual overall return string memory. It returns this. Right? Or you ain't like that. Or you ain't like that, Willis. Alright. So that's pretty dope. Alright, so that's pretty dope right there, guys. So, yep. So this function returns our metadata, which we'll get later. And a function that pauses the contract. Function paused. Can you see my eyes? Function set pause. Bool. Public only owner can do it. Pause equal value. So this is actually a simple function. Just okay. If you call this set function pause, the value put in on the front end, this boolean is now set to true, and it says if this goes true, then it's pause, so you can't mint no more. All right, this function withdraws the ether from the account. It allows the man of the hour, the person who created the contract, to get his rightfully dues paid. That was extra. Why did I do that? I don't know. Function withdraw. It's a public only owner. Alright. Get access to the owner. Address. Makes sense. Owner equal owner. Called the owner function. Unit 256 amount equal of address. Ooh, no. Address. This contract balance, right? You set a bool sent. It's a true or false. Equals owner dot calling the value, which is amount. Value amount makes sense. And it usually has this string right here. I never knew what the string meant, but it works, guys. And you require sent to be true or false. It is false. Failed to send ether. And ideally, you don't want it to be false, right? Cool. And you have all these two black sheet functions, a fallback and a receive function. Receive is a function that allows you to receive the ether, and a fallback, the fallback if the ether receive doesn't work. Right? So receive, I can spell receive wrong. External payable. Boom. Fallback. External payable. Boom. I don't spell receive wrong. Boom. Boom. Save. And the contract's done, guys. Wow, we just created our own smart contract. Let's see if everything is compile hard hat. Let's compile it. So you want to compile it. I didn't say this. You want to compile if you're done. npx compile hard hat. Oh. Yeah, sounds clear. Npx compile hard hat. Oh, you're playing with my money now. Npx compile. What? Okay. Yeah, oh, it makes hard hat compile. I'm I'm like, yo, this seems too good to be true. All right, clear. Gravy boys, gravy boys. Okay, now we want to deploy this, guys. We want to run this. We want to connect this to the front end of our app, which we'll be creating in a moment notice. Let's go to our scripts. Let's create a new script called deploy.js. Within this script, we're going to need something, guys. We're going to need environment variables because we're going to connect this to the Ethereum blockchain using Alchemy in a minute. So this npm install us. We're going to have this for later. npm install dot env. Just know we're going to need you. Just know we're going to need you, guys. But in our file, let's get access to the ether.js library. So const, or hard hat as well, const ethers equal require. You can get this through hard hat. Require hard hat. We didn't set it up, but we will go right here a dot environment file, which we're gonna have our Alchemy API and our rank B key, right? We have not dealt with this yet. We will be with this in a moment's notice. Good. You want to finish this, okay? And now let's require dot env dot config path dot env. Cool. But now that's where this bad boy comes in, and this is where Alchemy comes in, guys. Alchemy. So for me, should be already logged in. Yeah. So me, I want to use this thing called Epic NFTs. And once you get into this this section of the video, if you made this far, congratulations. You're a boss. And let nobody tell you otherwise. But here's the kicker, guys. This is what we're going to do. Once you set up a sign up and you create your app for your Alchemy, you're going to access your keys and you want to get hold of this Ethereum API key right here. Control C, copy paste that bad boy. Go here, boom. All that simple. Not even too fancy with it. Now, I'm not going to show you this, guys, but you tell your MadMax account, you go to account details, you enter you export your private key. You don't need your private key. I'm gonna do it over here. Actually, the different account too, so I don't get robbed. Does my account too have money's in it? Yeah, I can make some shake out of that one. Cause y'all take my account too. I ain't tripping too bad. But y'all take my account one, then yeah, that's GG's for me. I can't have that. I'll be hurt. Like, I'll be really hurt. Alright, once you have these installed, yeah, I know it's like, what is he doing? What is he doing? No. I skipped a lot of parts, but I just want to get the point across. Alchemy API equals cons rank B key equals process m dot rank B key process m dot alchemy API. Alright, guys. So once you set your environment variable, which never should be in here. Once you have your environment variable up and you have your hard hat and you mean your API placed inside and you have your key placed inside, you want to go to your hard hat config and you want to access those values and have them in here, because now we need to put the network and access the rank B blockchain through this hard hat user config object export thing with Jiggy right here. So let's do so. Let's hit networks. Our network we're using in this case is not the main net, but it's rank key by, and those take in two I leave the words for them. Values. Let's say URL. I'm just gonna say URL. What is Alchemy? There's Alchemy API right now. It takes into account, which is your rank key. Control S, save, and let's go back to this. Wow, Cindy, you're missing a lot of steps. Here, create a new folder called constants. In that folder, you want to create a new file called index.js. Woo! And this is where things get crazy. I didn't show y'all at the beginning of the video, but this is where Panata log in, and this is where this thing called hard hash lips art engine comes in, and this is where you are able to pretty much quickly and easy correct the metadata and create multiple images or multiple variations of your NFT if you're using the 721 standard. If you're not, then hash lips has no use case. JK, it does. I'm playing. Shout out to this guy. He's awesome. He's a South African dude. The motherland. Hey, but anyways, I already had this already installed. I'm actually going to just create a new window. Actually, right there. Now I'm breaking my computer. I'm gonna bring out their steps. I feel like I love y'all. If y'all watching this, I love y'all. So once you sign in to this bad boy right here, your Panata account. You need your Panata account because it's about to get crazy. Once you get cloned this, right? I already have installed, but you will get cloned, and you would clone it from this thing right here. That's not the point. Just close this. And you're going to access this page right here. Then you're going to want to navigate to the config.js page. And what you'll see will be very different to me. Everything is already modified to my likings. But here's the kicker, boys, and this is how we're going to execute. So, change your name prefix, your description, of course. And it comes pre-adjusted with layers. I edit my layers to have, just plain stuff in it. That's cool. Once you have that layers, you're usually going to want to run npm run build, and once you run build, it's going to build out your images and your JSON directories, and you get your your nice images, your random images and stuff. Within the JSON builds out the standard. This standard is based off the OpenSea standard. So if you ever do like NFTs, you gotta buy by OpenSea. They're kind of like the king of where you buy NFTs at. I don't think for long, because it just does not. It's not sustainable. But my FYI. Description, they have description, external image, name, and your attributes of your NFTs, and it's based off the standard, and your standard of metadata has to reach that standard. But what we're going to take a look at in Panata is the image description. How do we access the images and display them on OpenSea? How do we access the metadata in an immutable way? Yes, you can use centralized servers like AWS, whatever you want, but we're going to use IPFs because we want to be decentralized. Ain't that right, boys? Oh, I thought my credit card was in the video the whole time. I looked back, I was like, I was about to say, like, real. But now let's do this. So do I have to redo it? Anyway, yeah, let's do this. Okay. Your images, right? So what you're going to do, all my stuff is already uploaded. I don't want to redo it, but I'm gonna show you this right here. You're gonna want to upload your images to IPFS, right? And you do it by exiting the folder, go to select, go to your hash lips. Where you at, baby? Boom. Hash lips, go to your build, go to your images, you'll upload that folder, right? And once that folder uploads, something's gonna pop up like this. This is what's gonna happen. You're gonna now have access to your photos on distributed network. Oh my god. Don't post your, don't, hey, someone exposes you and put you on IPFS, it's always gonna be on IPFS, alright? So if you don't like somebody, You want to mess the life up? Put them on IPFS. It ain't going nowhere. You didn't hear that from me. So after you do that, you want to do the same thing with your JSON file, which is this. Blase, blase. Just, you want to do this. You want to upload folder, select. Same thing. Hash lips, build, images, upload. And what happens now? Let this bad boy load. You have access to your JSON file. But here's the kicker. You're going to need this CID of your images, because you need to access your images and you need to be able to upload it to your JSON file. So what I just told you, please take that back. So, because once you upload your images, right, you're going to now want to put this base CID right here. Copy that. Paste it right here. It's already good for me. Paste it right here. Then you want to do the step. Then you want npm run update info. You want to call this and then utilities update info. We'll put update all your base URIs in your JSON file to this CID. Then upload your images to the IPFS. And now we have a new CID. Then you want to copy that CID. Then you want to go back to where I'm talking about. Dude, I let all my contracts go. Like, bro, what happened to all my bro stuff, man? Like, bro, what happened to all my bro stuff? Then you select that folder. Yeah, save it. Now we're back in our index. It's called const metadata URL equals IPFS dot / boom slash. You have to add that slash because that's what the slash is with the one JSON and 10 JSON. That's what the ID is gonna be. Cool, right? Just save that bad boy, you know. Save that bad boy. Ain't nothing wrong with it. Save that bad boy. Then you want export. Oh no, module exports equals metadata URL. You know what I'm saying? Now we gotta export. Let's go back to our deploy thing. Now we can const metadata URL. Yeah, I don't know why it does that sometimes. Should just put that equal require constants. What if we get access to our metadata URL? Now we can call our function that's going to deploy our contract to the rank B testnet blockchain, which is going to be cool. All right, let's do this bad boys. Let's call a function const main equals. It's gonna be asynchronous, of course, because you know we're gonna be promises and stuff. You're dealing with block database and stuff. You gotta do that stuff. All right, facts. Okay. We gotta make sure we get things right. All right, then it's called the contract. We used to do that by calling cost anti-contract equals tract equals wait ethers dot get contract factory. And what's cool, we go back to this with contract card build NFTs, boom, paste dot save, get access to the metadata. Const metadata equal metadata URL. All right, it's now let's deploy the contract equals const deploy contract equals empty contract that deploy. This takes a constructor. Remember, our constructor takes a base URI, which is our metadata URI, boom. Now let's console Cool, we're done. Yeah, then console.log console log the address. That's pretty much log. Alright, console.log. This is our contract address. Boom. Deploy contract.address. You don't need to have to wait. Now let's call our main function in a try catch promise. Main then if it works, process that exit 0. Right? Failure is 1. Yeah. If it doesn't, catch that bad boy. Console.error process.exit 1. Awesome, guys. Awesome saucy. Now we can close this terminal out. We can view new terminal and CD back to our video contract. Let's call this npx hard hat run scripts deploy to see if it works on the local environment. I'm astounded. What do you mean? I am astounded. What? You probably try to import the hard hat model from your config file. You probably try to import it. I don't know what you mean by that. Houston, we have run into a problem. Houston, we have run into a problem. And nobody's done what the problem is done. I realized what I did. Okay, I realized what I did, guys. So in my alchemy, these weren't the right statements. I don't know where else see my key. These weren't the right statements, so see if that works. Oh my goodness gracious. Oh my goodness gracious. Oh my goodness gracious. See if that works. Oh my goodness gracious. You probably try to import hard hat from your module from your config or import it. And hard hat can't be initialized. Ooh, I fixed it. So what I have was, again, guys, I had this right here. I don't need that. Okay, clear. Ooh. Clear. 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 Full dice. Okay. Oh, you're making me angry. You're making me angry. Okay, I didn't fix this. Okay, I don't need to show you anything. It's just that I didn't fix variables. Soup. Copy. Rank geek. Doesn't matter to me, guys. As long as we get the product finished and we execute it, we're good. Okay. All right. Now we want to do npx hard hat run scripts deploy JS We want to access the network by doing --, rank eBuy. --, remember guys. Our contract is undefined. What do you mean? You're playing with me now. You're playing with me now. It's not. You know what? You may do the network. Let's just do run scripts. Deploy. Y'all see me having errors live time. I'm not even. I just did this, so I'm confused. I know why I'm confused. I forgot I had to wait. Gotta have a wait, man. See, the thing is, we're not patient enough. After years of searching and wandering in the forest of code, I figured out the problem. So what the problem was is that I had brackets around my metadata URL, and that's why I couldn't find the lane. I just took those away, copy, save, Google, npx, hard run script /deploy.js, voila. We print out our contract in our local environment, but we want to do this onto the rank B network, and as you said, we can do that easily. Clear, same command, npx hard hat run script /deploy.js, --, for double love, baby, network rank eBuy. See what that gets y'all guys. It gets us something interesting. It produces a contract onto the Ethereum blockchain. I was waiting for that big drop right there. Copy paste that. We're gonna keep that. Alright guys. I tried to make a whole new one, but we're not gonna need you no more. Delete. Hope I deleted the right one, guys. Just this. Okay, look like I was hovering around this. If I delete the wrong one, I will be butt. But anyways, cool. Remember this address. So we gonna. This is the address terminal. Remember that, we're not gonna close you out. And we're going to cd. Alright, just keep that in access, because in this address terminal, we will be accessed, not this terminal, but we will be needing going back to the cage, the artifacts, the build info, the contracts, ERC20. And we will be looking at this JSON file because we'll be accessing the API, and we will need a contract address. But we will come back to you, and we're going to cd back to video NFT. Now we're going to create a Next.js app so we can contact our contract. Simple. This is the fast part. Easy. Bad. So let's do it. Create Next app. I forgot. npx create next app at latest. Excuse me if I'm not wrong. Yep, my app. Cool. Gotta fudge it up, guys. What else? Creating, flex your muscles. I ain't been in the gym lately. I still got some on me. Coder who works out. Coder do a lot of things. I do a lot of things. I don't like to say too much, but I do a lot of things. Alright, back to why that is done downloading. We will now we'll clear this. We will cd to our my app. Boom. See, now we got our next app with our pages, our index. We don't need none of you. Delete that. Yes, you can. Yes, you can. Keep that. Delete that. All we really need is, we get to it, guys. We get to it. And it's npm install some dependencies, like npm install ethers, which we're gonna need. Go npm install back to npm. I be my mind go away. npm install web3. While that's downloading, just nod your teeth. Clear. npm install web3 module at latest, because they be updating late, they be updating new. Those are 3 dependencies that we're going to need. While that loads, definitely will be using. Alright, I didn't know it was done. It's done. Interesting. Cool. Let's import our Web3 dependencies from the libraries we just installed. Okay, it's import. First import React, and then import use state, use effect, use ref from React, because we will be needing those. Let's import ethers. What else we need? We need contract. We need utilist. Right? And providers from ethers. Import Web3 from Web3. Import Web3 module from Web3 module. So we needed those installed. And why are we here? Outside of our pages, let's just create a new file let's create a new folder called constant. With that folder, let's create index.js, and this is where we come back to our video contract with the contracts, or no, with the our contracts, ERC, JSON. We want this ABI bad boy. This makes it easier for us on the front end to call the necessary functions of the contract. It makes it very simple. That's why we get the ABI, which accesses the smart contract functions. So when we go back into function, let's export cont ABI equal copy paste. Save. Now here's where we saved our address right here from in this term. Right, I didn't save it, guys. So it's export export cons NFT contract address equals boom. Control S to save. Now we're out of that. And what are you? Is there something confusing? Directive is too fat open. It's too fat. All right. Now let's import that. Import ABI from constants NFT contract address from constants. Now we got that all in, guys. Now let's just create a header call. Call it. This will allow you to mint a NFT contract. Woo, get big. Alright. Then that, let's create a button called mint me. Woo. Contract save. Alright. Okay, so there's a couple functions, a couple states we want to check when we are connecting to a dApp. We want to keep track of the account address, of course, or const account address, set account address, equal use state will be empty string. Check if user is connected. Const is connected. Set is connected. Equal use state false. Set it false. We want to check if transaction is loading. Const loading, set is loading, equals use state false. Cool. Now we wanna now what else we wanna do? I forget, guys. I don't wanna get it wrong, so we use my I think I'm missing something. Set it's connected. Set loading. We want to check if count address. Check if it's loading. Check for token. Yes. Token amount. Tokens minted. Cool. We go back to that function. And set state. Set reference to Web3 provider object. Const Web3 module ref equals use ref. Cool. Now let's create a use effect that on load the user connects to the link that it prompts user to connect their MetaMask, but requires it to be the rank eBay network. Okay, cool. Okay, use effect. Okay. Now here's the thing. If we're not connected, we want const Web3 module. How do I do this right? It lost me, guys. I had it just now in my brain cells, but I forgot. I forgot it. We want Web3 modules.ref current equals new Web3 module and take in as an object that the network will be ranky by comma provider options. Should just look at the docs for this. This will be boom disable false. Cool. Save. And we're gonna call it connect function ever. Cool. Now above this, we're gonna create a function that gets the provider, which is, you know, MetaMask or Trust Wallet, for example, or Coinbase, wherever you put in your dApp, and prompts for signer in some instances. We'll see. Okay, const get provider or signer equals async function. All right, if need signer equal false. We'll see why we put that there later. Arrow function. No, I don't know. To me, arrow functions just look good. Like, you know, this is it's like this, like async function. Like that's cool to you guys. Not to me. Anyways, let's get access to the provider. Const provider equals wait web3 module dot current dot connect, because we actually have it already. Now we're connected to the provider. Now let's get connected to let's create the web3 provider by accessing from the function from the ethers library. Get web3 provider. Const web3 provider equals await. No, new providers. So we're creating .web3 provider. So we're creating that, and we're using this as step. Yeah, so far. Okay, now let's get access to the signer, which will be const signer equals web3 get signer, which gets the person who is calling the mint function, or the sender or the signer of the contract, which would be you on the front end, the user, me, you, whoever's behind the computer doing stuff. Now we want access to the address to see who's connected, right? Right. So you const address is equal to signer get address. Quotation marks. All right. Okay, let's split the address. Let's split the address up. And I remember this function. I actually have it up right here, but I'm gonna code it out, show you how we do. So I could cut a function called split string, which takes in a string specified, and it let result one function split chain. No, so you don't const split chain. You got that. Say let result one equals string dot substring. Yeah, string dot substring 0, 0 and 4. Let result 2 equals string dot substring 38 and 42, the length of the Ethereum address, 42. Then let substring address equal result 1 plus result 2. Then let's return substring address. Let's change that. Now let's say const substring address equals split string on address. And set count address substring address. It's const.long address count address to see if it works. Cool. Now let's check if the count is connected to Rank UI network. Many ways you can go about this. We're gonna use a window alert. So we're gonna check for the chain ID. So chain ID equals await it provider sign. No. Web3 provider get network. Now if the chain ID is not equal to 4, which is used for the rank B network, we want to window.alert, please change to the rank B network. That's all we want to say. We're not going to keep throwing no more errors, so it's spamming these boys. We don't need that. Okay, but if we need a signer in a transaction prompt, user must, or me, contract must specify it. So if need signer, const signer equals web3 product get signer, return signer. And in this function, we just want to return web3 product. Now we want to. Now that's cool. Now let's create. Let's create a function that connects us to the Web3 network. Const connect equals async. Let's place it in a try catch block. It's simple though. You do try await get provider signer, set is connected to true. Once it gets it, catch console.log Shaggy, why are you not working? Okay. And let's call this function connect. That's what I want to do, right? I like to make sure I'm on stuff. You know what I'm saying? Make sure I'm on stuff. Yeah. Cool, guys. So on that note, skis, let's go over here. Let's cd to our my app. It's npm run dev. And on that note, let's see something. Let's go to our local host. Rate not defined. It's not supposed to be just a let's see, we got everything. Hit it with that substring is not a function again. Now I've been seeing that stuff a lot. He telling me substring is not a function. That's the thing. Why? Substring is a function, dude. Every time it does it every time, and I'm like, bro, you are a function, are you not? If you're not a function, then I must not be a man of my word. Let me get outside more. Cool, a lot. Look that money, JK. Says substring is not a function, which takes in a string dot substring returns the address. You know why? I do this every time. You wanna wait, get signer, get address every time. Look, and it works. We're connected. It doesn't prompt me to connect because I already was connected. But now let's create the man every time. Like, dude, I find it funny. I find it really funny. What did he do? I'm about to show y'all what I'm doing. Let me make sure I got everything right. Okay, simple. Now we just want to create the mint function, which is the last part, guys. Create the mint function. Woo! Function. Let's call it a mint with a capital M. Correct. We're acting a little brazy now. No, that's not how you do it. Fonts mint. Ooh, nah, that's too regular. Mint equal async. Function. Awesome. And since this is connecting to a database, we want to usually use a try catch block. So try catch error. But in this block, we want to get access to a signer. So we set signer to true because we are writing to the blockchain. We are minting, which means we are writing a contract to the blockchain. Cool. Signer equals await it writer signer true. Alright. Now we want to initialize a new contract, or simply just get access to our contract, right? So cause NFT contract equals new contract. what takes an empty contract, ABI, and a signer in that order. It has to be in that order, or the contract doesn't work. All right. Now you want to call the mint function from the contract, right? So we call it tax equals empty contract mint. Within the mint function, though, we have to specify the cost of the NFT, and we have to parse it to ether, and we do that by calling the ether's utilis function from the ether's library. What do you mean by that, Sydney? That's value utilis.parse ether 0.01. That's what I mean. Then we set is loading to true. Then we have wait for. Then we're waiting for the transaction to get mined. Right? Await text that wait. Once it's mined, set loading back to false. Set it loading false. Alright, then you can do window.alert. You just minted your first NFT. And you say that. Okay, now we're already there. We're done. Watch this. Call that. How dare you? How dare you? It's an invalid signer or correct. I've never seen that one before. Oh. Oof, 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 oof. Oof, oof, oof. Oof, oof. 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 Oof, let's do something. Index. I go CD video contract. Index hard hat run scripts deploy.js network run keybind. Let's do that again. That was weird. I just got rain checked at the rim. I got rain checked at the rim, guys. It's always something. I swear, dude. It's always like you can't. I definitely deserve me some Chipotle for lunch in a book. You gotta be a good book, guys. I'm not gonna put it too political. I'm gonna put it in. This is the book I'm putting. I would teach you to be rich. Can we all about that investment? Thesis, boys. Alright, copy that. Let's go back to let's change this. And let's go back to the cache, artifacts, the building for the contracts. Let's try this again, because maybe that was the problem. Save, go back to index. Save. Reload the page. Go back to index, save. Alright, so I'm doing something that's wrong with me getting access to my signer. The async function, which is interesting. I want to fix that. So, according to my current state of knowledge, we have provider, await, new providers. But yeah, get the correct signer with New provider. I'm going to copy and paste this. I think I may have been missing that. Sorry about now. Valid argument. You're playing with my mom. You're playing with my money now. Now you playing with my money now. I think I figured out the problem. I'm looking at it. I'm looking right at it, guys. I know you're probably like, what is he doing? Texting that way is not a function? What do you mean? Connect text await. TX dot wait is not a function. It says it's not a function. Guys, we have someone who wants to be different. Text is now wait is not a function. That is new to me. It's in the async, it's in the try catch block. Actually new, I never seen that one. Yeah, that was weird. Never seen that one. You know why? You gotta add a weight to these things, guys, and that's what messes me up. So now you don't see that function. But anyways, you should now be available to mint your own NFT. Confirm it, guys. You go to the blockchain. Let's just see a transaction. View on the block explorer. Little low. Ooh. It's a long transaction. I'm not editing nothing. Well, that's a long one, eh? Yeah, but that's a long, that's a long. Yeah, I meant it. View on popular. So you met from the video NFT. So now you go to your contract. You are one owner of your contract, and look at that, guys. That's how simple it was to make an NFT. It was very simple NFT. So I hope you enjoyed the video. I hope you understand some of the mechanics. I'm not really used to doing tutorial videos and teaching people, so I'm gonna get better at it though. Alright, this is how you mint your own NFT. Code example. Thank you for joining. Make sure you like, comment, subscribe. I helped you out. Follow me on TikTok at Slim Sid. Follow me on Instagram at Sid the Science Kid. Alright, y'all have a blessed day.